Production is based on quality producers. Some people are quality producers as Halliburton, some people are not. So my landowners, is up to you to police your own land. That is what you're going to hear from me over and over again. I hate to say this, the squeaky wheel gets the grease. So one of the sources of emissions that we have are what we call intermittent emissions. These are from the initial stage, drilling, hydrofracturing, well completion, and pressure relief events. They're not exactly intermittent, but pressure release events happen a lot. We qualify the different stages because at different points you're going to have different volumes of emissions, and I think that's important. So this is what we call the initial. Now, one comment here. When we talk about an intermittent and a temporary, be aware that when you're talking about one pad site with 32 wells, you're going to have 32 times that thing is going to get drilled in order to put a well in the ground. And then they have to come back and re-stimulate them. So the intermittent rig that's near my house doesn't seem to go away. It seems to be there an awful lot. Go ahead. Then we have continuous point sources. And the continuous point sources are the compressors that are stationary on your property that sound a little bit loud late at night. And the tanks that are there. A real good average is you have one well, you generally have 2 tanks. You have 2 wells, you generally have 4 tanks and a compressor. Now, I realize it depends on how much water's coming out of there. I happen to bring this picture because I happen to like this picture a lot. You can see the good quality tanks in that center. The tank to the left, it's a little hard to see, but at the very top there's a net. To the side where it says 2009, that's the top of the tank. The tank blew off in a pressure event, and they are actually violating the Migratory Bird Act. So they had to put a netting over the top of the tank because the tank no longer has a lid, and it's legal like that because they don't violate the Migratory Bird Act because the birds were swimming in there and they're not supposed to swim in there. But it still pollutes the individuals, but that's not a violation. Next. And then we've got the continuous fugitive sources, and these are the ones that they leak. I mean, this is a combustion process. Get in your mind that this is much like your engine in your car. You've got leaky valves, you've got leaky all sorts of flanges, valves, everything like that. It's going to leak. Eventually it's going to leak. If you don't do something to your car, you're going to have the same situation happen. That's what happens here. So a lot of these couplings and these valves and these flanges degrade over time. They have to be replaced. If you've got a good operator, the operator replaces it, keeps the stuff working pretty well. Next. So, the chemicals I'm talking about, because my focus here is chemicals. What chemicals are we going to be exposed to? And we're going to go into actually what chemicals will do to you, which is even funner. So the chemicals are basically 3 categories. They are the natural gas product. You're talking about methane, ethane, butane, propanes, aldehydes. There's sulfur compounds that are associated, which are carbon sulfide, carbonyl sulfide. I've got about 15 different sulfides that come out of my air emissions. There are varying kinds depending on all sorts of things. And then we have the VOCs, which you keep hearing the VOCs. BTEX, capital B, capital T-E-X, is basically benzene, toluene, ethylbenzene, and xylene. These are not your friends, but you're going to hear a whole lot about them. They are emissions that come from a combustion process. And there are many different kinds of, methylbenzene is just, toluene is just a methylbenzene. So we're going to get into a little chemistry class. It means it has a methyl arm like this. You get into some of these other compounds like 1,3,5-trimethylbenzene, it kind of looks like that. 1,2,4 kind of looks like this. All right, they're all a benzene product. They're not necessarily good for you. Again, this is one of those things where you're talking about chemicals, concentration is key. So all the data that we accumulated, we actually put into this wonderful computer, and it jumped up and down and turned it sideways, and it spit out some correlations. The correlations we came up with were actually very interesting. This is the percentage of chemicals present when methane is present. And what we actually determined was toluene was present 94% of the time that methane was present. And M&P xylenes were present 86% of the time. Dichloroethane was 80% of the time benzene, et cetera, et cetera, et cetera. This tells you that if there's methane, chances are you're going to see something else. That's all it tells you. It tells you that toluene is almost always there. So this is good to know, so we have a parameter of what are the chemicals that we're going to be seeing consistently. And again, this could go on and on. I stopped at 50%. So I brought you an idea, because this is like, okay, this is chasing little invisible butterflies is what I do for a living. And it's real difficult for people to say, but I can't see it. So what I brought today is a little bit about the city of Dish and what happened in the city of Dish. This is our little case study. The city of Dish has a compressor station. It's not just one, but there are 5, side by side by side by side. They do this so that I can't figure out where it's coming from. I've got the emissions tracked, but they say, well, who did it? And I'm like, I don't know. There's 5 of them right in a row, side by side by side. So I can't blame that guy because this guy has emissions too, and I can't blame that guy because this guy has emissions too. And I look at TCEQ and I go, I don't know. And they look at the Railroad Commission, not me. There's an MOU here, a Memorandum of Understanding. We don't do air emissions, that's TCEQ. In the meantime, the people are choking. I don't know. We can't do anything about it when they go side by side by side by side, 5 different companies. You cannot isolate emissions that way, and therefore you cannot isolate fault. Brilliant. Next slide. So what we have right in the middle of that bullseye are the 5 stations side by side. What we have surrounding that is a residential area in Dish, Texas. This is the infamous Dish. If I had known about all the trouble I'd be in from Dish, Texas, I wouldn't have agreed to test there. But anyway, so the inner circle is what we're looking at right now. The red point on the inner circle is where I set our monitors, and I monitored for 24 hours. I want to know, out of 24 hours, what kind of emissions did I get out of here? What chemicals did I see? And what we determined was we had a fairly high concentration of methane. So we know we're getting lost product. Talked to one of the CFOs of one of the big companies, one of the big gas producers, and I said, why are you guys not capturing the methane? He goes, I don't know. I've been telling the guys, the technical guys, for years. We're losing millions of dollars. But it does come down to dollars and cents. Is it cost positive to actually go after the product, or is it not cost product? You know, and that's what they have to determine. So they've determined so far that there are different processes, and there's still going to be lots of leaks with this. So we've got methane. We've got benzene at a low amount, though. That's not really high. That's not something that I would get really excited over. And again, these are 24-hour concentrations. We'd have to calculate them, do a little formula recalculation in order to determine what they are for a 1-hour concentration. We've got dimethyl disulfide down there. Look at that. That's 52. These are in parts per million. I'm sorry, parts per billion by volume. So that one's a little high. But overall, I said, you know, we count product, we count emissions per chemical, but what's the cumulative effect on people? Well, the cumulative effect is people are getting sick. Now, I can't tell you which one of those chemicals is getting them sick, but I can tell you it's a bad soup. So then I said, all right, let's go out. Oh, by the way, the first dot is about 2,150 feet. So I said, let's go out another few feet and measure further on. I mean, I would love to have done 10 of these. They're expensive, so I could only do 2. But then we measured another 1,000 feet out in the next slide. The other 1,000 feet out, we came up with methane had reduced to 2.1. There's a process where the atmosphere basically moves. Nothing is static in the atmosphere. It's here 1 minute, gone again. Benzene went up to 12.30 parts per billion. But that's, again, a 24-hour concentration. It turns out to be somewhere around 30 parts per billion when you calculate it to a 1-hour comparison of the TCEQ's 1-hour comparison. It's not a good thing. And we just went on and on. We've got toluene at 61.7. We've got the benzenes, MMP xylenes, at 46.2. This is where we started to see really sick people. And how far